Hello class, welcome to this second screencast. Today we're going to be talking more about sockets and picking up where we left off in previous classes. In the last class we talked about the getAddrInfo and how that call utilized the DNS to take a host name and convert it to one or more IP addresses. And not only that, but IP addresses of either version, IPv4 or IPv6, for later use in the connect system call with a socket that we have. Today we're going to take what we've done so far with the client. We've mostly focused on the client side of things with the client-server paradigm in the networking, in the network programming world, and we focused mostly on the client. So now we're going to put everything together, or take a step back and understand the interactions between client and server and how those the different functions are used on both sides in preparing sockets for this communication. So we're also going to look at the order in which things are done. So this diagram shows kind of an overall view of what we're going to do, and we're going to step through these things bit by bit in today's lecture to kind of go over them and make sure we understand what's happening. Okay, so first thing that happens, we have to have some sort of a server listening on some remote host. Okay, again, this is client-server communication, which means a server has to be listening somewhere for a client then to initiate connectivity or some type of communication to that server. Server has to be listening for that to happen. These are the functions highlighted in gray on the right-hand side that we will be talking about for the server to get into the appropriate state for a client to communicate with it. Okay, once that's done, the client can begin some type of communication using the steps that we've talked about, using getAddrInfo, again to take a name, convert it to IP address, using the socket system call to actually create a socket, and then connect to associate that one of those sock adder in structures with a port and an address to associate those with the socket itself, and in the case of TCP, to make establish the three-way handshake to establish a TCP connection. Okay, once that has happened, we can now exchange data between the two. Now this is, I'll mention this here, once you have this connection established, or this communication established, more generally speaking, you can send in both directions. Okay, typically what happens is the client is going to begin sending first. Okay, but really it can happen in any order. And you can send back and forth as many times as you need, using the write or send call to send things, and then the read or receive call to receive things. So this can go back and forth depending on whatever protocol is that you're speaking, and we'll talk more about that in the next class, putting those things together. One thing I should note while we're at this point, the connect call that we talked about earlier on the client side, that is required for TCP. Okay, we did the example in class where we initiated a connection, but the server wasn't listening on the other side, and the connect actually returned with a -1 because it failed. Okay, because there was no server on the other side, so the three-way handshake failed. Okay, that's required because you have to have, it's required for TCP because you have to have a reliable connection. And the call to connect will let you know if it was in fact successful in establishing that connection. However, on the UDP side, we can still call connect. It is not required though, like it is in TCP. All that connect does in the case of UDP is it tells the socket that further datagrams that are sent to that socket, here is the destination that they should go. Okay, so that's what connect does when you call it with a UDP socket, or a socket of type sockdgram. Okay, and let's see. So anyway, that's a difference. One difference between a TCP socket and a UDP socket with regard to the call to connect. Not required for UDP, is required for TCP. Okay. And if you don't use connect with UDP, you decide not to. There is another system, another version of send. It's another system call that that you can use that will tell you where to send the datagram. When you tell it what you're going to send, you also tell it where you're going to send it. It seems a little silly to do that, which is why Connect is so useful, but you can actually do it on a case-by-case basis if you want to. And the function that you use for that is called send to instead of send or write. Okay. Now finally, once you're done with all the reading and writing between the two, what typically happens is the server's usually accustomed to sticking around, okay, and handling additional clients, and so it's not necessarily going to do anything. It's not going to shut down or anything like that. Whereas the client will disconnect, calling close on the socket itself, just like you'd call close on a file descriptor for a file. Okay. But at that point, the client disconnects, and then the server will drop a client. It can go back into the loop and accept a new client. Okay, so we'll talk more about the server side today now that we spent a lot of time on the client. Okay, just by way of review, we haven't really, I showed you some examples with this, and I won't spend a lot of time on these next couple of slides, but what I do want you to know is what some of the structures look like. Maybe that'll help you understand a little bit more what's happening here. Okay, so we have this generic socket address, okay, which we call a sock adder. This is kind of a, think of it similar to polymorphism, meaning that this one really doesn't have any specifics. It's just going to, we're usually going to cast one of the more specific versions, a struct sock adder in or a struct sock adder in6 for IPv6. Okay, and there's even another type that I won't talk about here in this particular class. But the point is, those are the specific ones. This one's the generic one, and so this is the one when you pass things into Connect that you will need to cast them to because it requires something generic. And then it'll look at the address family to determine which version it's actually going to use, IP version 4 or IP version 6. Okay, but anyway, that's what struct sock adder has. Here's the more specific version for IPv4, which is called a struct sock adder in. And as it says here on the slide, it must be cast to a struct sock adder to be passed in for its use. Okay, but this contains the family, the port, and the address. And if being used as an argument to connect, then this is going to be the destination port and address that we're looking for. Okay, so let's talk about socket. I've shown you this in examples, but we're taking in a socket a domain, and that's what we've talked about is the address family. Okay, AFINET stands for IPv4. The type is either going to be datagram or SOCDgram for datagrams, and SOCStream for TCP. Or byte stream, and we'll talk more about what that means in further classes as we go along. Okay, so again, getAddrInfo will populate these for us, or at least it'll give us members of the struct. Each link in the linked list, okay, will have members to fill this in with, like in the example code we've given you, and we that code will be provided to you, the code I've used in the examples, so that you can use it yourself. Okay. All right, so let's talk a little bit about this one on the right side. Both the client and the server are using getAddrInfo, and you may ask why the server would use getAddrInfo. I'll show you some examples of that later, but they both can actually use that to get things started. And then you have the socket call to actually create the socket. Now let's talk about what binding means. To explain binding, let's first consider what it means to connect. Okay, with connect, we have the we're taking a struct sock adder, which again contains an address and a port, and we're associating that with the destination side, where our datagrams or where our connection for TCP, what's the remote side of that connection. Okay, and that's what's happening with connect. But we haven't talked about what's happening on the local side, okay, of a connection, or in the case of a server, how you're going to determine what port you're going to be waiting for connections on for an incoming, and that is done with bind. Okay, so bind serves the purpose of taking a struct sock adder, which again includes an address and a port, and determining the local side associated with that. So bind is for taking local address and port and establishing that with a socket. Okay. Now, in this diagram over here that I just showed you on the previous slide, we don't see bind on the left-hand side, but it turns out bind is optional. For some reason, you wanted to determine the source port for which you were going to from which you were going to send communications to a server. You could actually call bind, and it would do that just fine on the client side. However, if you do not select it, in other words, if you don't use bind on the client side, the kernel will choose the source address and the source port for you, as we've talked about in class. So the summary here, bind can be used on the client, but is not required and typically isn't. Whereas bind is required on the server. You must bind to a given address and port. Okay. So that is a summary of bind. Okay, let's talk about listen now. Now, listen is required by the server, but only if it is a TCP server. Okay, listen does not apply to something that is listening on datagrams. Now, you're going to have to make some changes to the code in the next homework assignment that's due on Friday of this week. You will be taking some server-side communications that are currently configured for UDP or a socket of type SOCDgram. You're going to be converting them to a server that uses TCP instead. And so you're going to be implementing this bind, this listen, and these things that are specific, basically noting the differences between a UDP server and a TCP server. Okay, so here's what's going to happen when we take this socket that we've created, okay, with the socket system call, okay, where we turned an integer that is a socket. We're now going to make that socket have a special function. Okay, this is not, when we call listen on a socket, what that's going to do, it's going to say, hey, this socket is only for listening for incoming connections. We're not actually going to use this socket for actually communicating in terms of doing reads and writes on it. What it's going to do, if we designate it as a listening socket using this listen function call, is it's going to say, hey, this is a special socket that will only produce other sockets that we can use for reading and writing. And so that way what we'll do is every time we get a new client, we're going to call a special function, which we'll talk about next, that will produce a new socket file descriptor that we can use for reading and writing. But by calling listen on this particular socket file descriptor, we will not be doing any reading and writing. Okay, it's just for listening. Okay, when we call listen, the first argument is the socket that we've already created. Okay, and by calling bind on it, we've told it which port we're going to be listening on. Okay, we called bind before. If we look again at this order. Okay, now this backlog, this is a number that will give us a hint about the number of outstanding connection requests that the kernel should queue up before it starts refusing things. So think of a busy web server that's getting requests all day long. If for some reason you get a request and your user code is not able to handle that request in a timely fashion, the kernel will say, okay, well, we'll keep up to this many requests in a backlog. When I say requests, I'm talking about the TCP three-way handshake that we did. The kernel will handle that and then say, okay, it's all ready for you, now come get it. Okay, and when I say come get it, it's with the next system call that we'll talk about, which is accept. But if for some reason you don't have enough backlog, then the server will start refusing those incoming connection requests. Okay, so that's listen. So on the server side, okay, we have get adder info, we have socket to create the socket. We are now using bind to bind a local address and a local port associated with this socket. Then finally, we're going to use the listen function call to say that, hey, this socket is now special to listen on the address and port that we've just bound to using the bind system call. Now, once we have that system call, we're going to call, once we have that socket established as a listening socket, we are going to use the call, the function accept, which is again specific to TCP, not to UDP. Okay, we don't need listen or accept with UDP. But with TCP, what we're going to do is call accept, and the first argument there is the listening file descriptor that we just had on there. Okay, so what happens is we're going to call listen. Okay, and we're going to call accept on this listen file descriptor. We're passing in the address of a sock adder and then the length associated with that. And what's going to happen is when a new client comes in, okay, and attempts to connect to us on the server side, accept will return, and the int that it returns represents a new socket that is not a listening socket anymore. Now this is a socket that we can interact with. Okay, we can read from it, we can write to it on the other side. And that adder, that's the second argument, is going to be populated with the information of the remote client. So that way, as a programmer, we can see which port and which remote address this connection was made from. Okay, and then the size of the socket address is in adder length on the other side, which will also be used in subsequent code. Excuse me. Okay, so in the end, this descriptor that's returned from accept is a file descriptor. It's a socket, but now it's one that we can actually do things with in terms of reading and writing. Okay, so that's on the server side. We've set all this stuff up, okay, along the way, and now we're ready to receive something on the connect side. Now this dashed line, this is just meant to say, hey, connect on the client side corresponds to accept on the server side. Okay, connect, which we've already done some examples of, on the TCP side, it is now going to we're going to call connect on this file descriptor, the socket descriptor that we've already created. We're going to pass in the adder that we have been that represents the remote port and address that we want to connect to, and then we have a length associated with that as well. Okay, in the end, when all this is done, okay, we end up with the for tuple that we've been talking about over and over again. Okay, we have on each side, so on the client side and on the server side, we've established a for tuple, which is source port, source address, destination port, destination address. Now, of course, those are flipped on the opposite side, the values of those, but that becomes a unique for tuple that we have been that we are now working with. Okay, and that's what things look like. You can see how it's represented in this slide as x:y being the client address and the client port, and then on the other side, on the right side of that within the parentheses here, we have the remote address and the remote port. Okay. All right. So here's let's illustrate this just a little bit because what I want you to see is how things, how we term something called blocking. Okay, so what happens is when we've set up this socket, okay, and we get to the next call, which is listen. Okay, on the server side, excuse me, we call listen, and then we're going to call accept. Well, that server code is just going to wait there for some client. So accept will not return until a client actually does something. Okay, it's not until the client comes in that listen returns, and then we get this new file descriptor associated with that. So we're actually going to, let's skip over and actually look at this a little bit closer. Okay, so we've got this server code on my remote host on the top side here, and we're going to look at the more sophisticated code. So first let's look at UDP. Okay, with UDP, we on the server side, remember I talked about in that one of those early slides that we are actually using getAttr_info as one of the first things we do, just like we did on the client side. Now, just to explain this a little bit, what's going to happen is we're going to pass in some hints, just like we did with the client side. Okay, we're going to specify address family unspecified, so we don't care if we listen on IPv4 or IPv6. Now, sometimes you actually do want to specify that. For the purpose of this class, it doesn't matter, so we can leave it unspecified. Okay, here's where we're going to specify the sock type, sock dgram for UDP. Here's one that is key, and this is a key difference between the server-side use of getAttr_info and the client-side use. In this particular case, we're going to set a flag AI passive, which means we're going to, it tells us we're going to be listening, okay, and we're basically looking for, this will tell us to listen on the wildcard IP address, and all that means is listen on any IP addresses that you have. Okay, so for example, my laptop, when it's plugged into my office, I actually have a wired connection and a wireless connection. So this is a two-interface machine. If I were to use AI passive, then it would tell it to start things on the wildcard, which means it would listen on both of those interfaces for incoming connections. Okay, everything else is 0 or null. And then we're going to call getAttr_info with those hints that we've just created. Okay, and then we can go through a similar loop. Now again, this loop is somewhat arbitrary, and it kind of depends on what you really want to do. And in this case, it's saying, hey, try on all the different links in the linked list to try to come back with an address that you should listen on, and then try one of them. Actually, in the case of servers, now I didn't write this code. This is one of the man pages. But in this particular example, oftentimes you'll want to do something a little bit different. This code here is fine. It's to to show to prove a given point. Okay, as an example here. But generally, you want to be a little bit more strategic than this in terms of just saying, hey, listen on the first interface you come to. But anyway, it works for our example here. Okay, so they're looping through. They're just finding the first port that can be bound to. And so we're again, like in the client example, we're calling connect. Here in this code, we're calling bind and making sure we can bind to some address. Now again, as just by way of reminder, bind is taking this here socket file descriptor, and it's associating the local port and local address with it, not the remote one as we did in connect. Okay, if we have some sort of issue, we're going to close that file descriptor. But if we're successful, then we're going to break out and just come down to this point. Okay, let's see. So we're going to go down here into this loop, and at this point in the UDP world, we don't have to call listen, and we don't have to call accept. Okay, as I mentioned previously, we're just going to go right down here, and we have this special call receive from. And what receive from says is hey, you're going to receive something, and at the same time as you're receiving some datagram from this socket, SFD, you're receiving it into this buff at most this many bytes. So it's just defined as buff size bytes. Okay, and then, by the way, when you get that, tell me who it's from. And so what it's going to do is populate this peer adder structure that we've defined previously, and we're casting as a struct sockadder pointer. Okay, and it's going to populate that with the remote address and remote port of the source of the datagram, whoever sent you this datagram. So in other words, the server will pass this information, the kernel will pass this information up to you so that the server, on the server side, the programmer can actually receive that information. You can put it in a log. You can say, hey, this request happened from such and such location, whatever you want to do with it. You get the remote address and the remote port. Okay. And then all we're doing here, we didn't, in my last lecture, I didn't talk about the fact that you can take similar to taking a name and converting it to an address, the DNS makes a way for you to take an address and convert it to a name, and that's what get name info does, but we don't have to be overly concerned with that. Okay, when we work our way down here, we're just checking, how many, we're using that name that we just received by converting address to name, and saying, hey, that call was successful. We're just going to print out the number of bytes we received that remote location. Okay, and then we're printing out the message here that we actually received. The reason why I'm putting a buffer on is because in our client code, sorry, a buffer, I put a null terminating, a null character at the end here, is that I did not send a null character in the client code, which means if we want to use that function like printf, printf looks for a null terminating byte. Okay, and so we have to have that somewhere in there. Now, one question I want to pose to you is, how would I know where to put that null byte? In other words, how do I know how long this string is? Okay, when we receive something over the wire, these are just bytes. We don't know whether these are strings, whether these are just regular characters, or arbitrary characters, I should say, arbitrary byte values. We don't know. There could be several null characters in there. Okay. Now, in my particular example, I am sending strings, but it could be that you're sending whatever. So here's the key: read or receive from. The return value from these is an integer that specifies how many bytes were received in that call. Okay, that were pulled out. In other words, how much of the buffer in terms of bytes was populated for that with that call to receive from or read or receive. Okay, so we know how many bytes were in this particular read, how many bytes we read from the network, and so when we come down here and add this null character, we can say, oh, okay, at nread bytes, put a null terminating character there, and so now we can. If we didn't already have a null character, this will be on our null character, and so we can print out using printf, and it will know where to stop. Okay. All right. So this is what it looks like on a UDP server. Okay, and we've got our socket call. We have our getAdderInfo call up here. We have getAdderInfo. We have socket, and then bind. Okay, on the server side, and then we can just start receiving. Okay, that's for UDP. So now on my server side, I'm going to compile this, and now we're going to run server x UDP 5599. Okay, and on this side over here, on my client side now, we're going to initiate. Let's go ahead and compile it, make sure it's compiled. Client x UDP, client x udp.c, and now we're going to run client x udp 5599. We're going to add 2, 3. Whoops. Oh, let's try this. Okay, and there we go. So as you can see, it's doing a reverse lookup from where I'm sending things. Okay, and so it's actually going the extra mile and saying, oh, here's the name, okay, associated with the address that's sending these datagrams. Here's the remote port associated with this address, and here are the actual messages sent one at a time. Okay, message 1, message 2, and message 3. Okay, that we sent on command line. All right, let's go back and do the TCP version now. Now, some of this is in your homework assignment, so I'm not going to go into great detail here, but I will show you some of this here, because I want you to be able to do this yourselves. Let's see. So we're going to actually just change this. I've done the TCP code, and I've showed you in the previous slides what you need to make this happen. Let's see. GCC -o server x TCP server x TCP.c. Okay, so now we're listening as a TCP server on this side, and let's make sure we've got things compiled on our client side. And now we're going to do the same thing. Okay. One of the things to note, we haven't talked a lot about the distinction between what's happening on between TCP and UDP in terms of reception. Okay, there's a reason why we call the type of the socket sock stream as opposed to like sock TCP or something like that. The reason why is because this is what's called a byte stream. But the point here is that when you're sending things over TCP with a socket type of sock stream, what's happening is these bytes are just getting piled up in some sort of queue, and you're just going to keep reading them as bytes. You're not going to distinguish them as multiple datagrams. And then when you call read, you'll read whatever's there from this group of waiting bytes. Okay, and in the case above, what you notice is in the first case, we got message, and then it said 1 and 2. Now, if you remember, the code is set up to send those one at a time, 1, 2, and 3. What happened here was that when we got notified there was some data, we went right. Both of those bytes had already been sent, and so we grabbed both of them at the same time and printed them out. Okay, with UDP, it's different. Every time you go to read something, you're only reading something from a single datagram. So you can't read from the next datagram over until you have a separate call to read or receive. Okay, so that's an artifact of what you're seeing up here in the top half. Okay, so that's kind of an example. Let's actually change things up just a little bit here so we can make sure it's clear what we're doing. Okay, so I'm going to go back. I've got server x UDP, and what I'm going to do is I'm coming down here, and again, I'm going to leave this as an exercise for you. What happens above this line with regard to oh, this is my UDP client, so it actually doesn't matter. But let's do this. I'm going to, in this particular case, I'm going to put sleep right in here. And I'm going to sleep for 2 seconds. So what this is doing is saying, okay, as a server, okay, we've called socket and we've called bind, and before those we've also called getter info. So now at this point we're just waiting for some incoming connection. What's happening is we're actually right here. Okay, when we get to this point, this particular call, it will not return until we receive some datagram. Okay, we're going to be receiving some datagram, and then it'll wait there until that's there. Now, obviously, with the sleep, this is going to wait 2 seconds before that, before it even gets there. So let's change this even. Let's make this even a little bit different. Let's actually put this sleep in the client side instead. Okay, so what we're going to do is just to show you how this works. So client UDP x udp.c. Okay, so what we're going to do is we're going to put a sleep right here. We'll put a sleep for 1 second. Okay, now we're not going to run that yet, but what I want you to see is now when we run this server, okay, what's happening is the point which we're waiting at is right when that data comes through. Excuse me, right. We're waiting at the receive from call. Okay, so we're right there waiting for something to come through. In fact, just to make this a little bit more interesting, I'm going to come in here and do a printf about to call receive from, so you can see this. And now I can say just returned from. How about that? Okay, so now we're going to go compile again. Let's see, this is our, which one did I do? Oh, I just did UDP, modified UDP. Let's go back and do TCP, since that's the one I just did on the bottom one. Okay, so let's change this one more time here. And in this case, things are a little bit different. What I'm meaning, we've done some additional work up here, which you're going to do in your homework. But I'm going to call sleep right up here. Oops. Ugh, I'm all backwards. Okay, printf about to call receive. Okay. Just returned from receive. Okay. And let's do that same thing. Actually, I'm going to do it right here. Okay. So we're going to, let's see. We're going to do something like this. And then we're going to go back and start up our TCP server on 5599. Now remember, what's going to happen here is first we're going to connect. Then we're going to sleep for a second, then send the argument, then sleep for another second and send the other argument. Okay, and so we're going to see how that works. Oh, it's because I modified the UDP client. I am all over the place. All right, let's try this again. Okay, so what we're going to do here, sleep. Okay, we've got our server started. Okay, so what we're seeing here, okay, is we sent data 3 times and we called sleep every time. So what's happening is when we do this, okay, receive is just waiting for us. It's not going to return until uh, until something is actually there. Okay, so it's kind of it's sitting there waiting. Let's just illustrate this even further by slowing things down to 5, so it's clear what's going on. Okay, and let's start up our server again. Okay, so it's sitting there waiting. It's about to call receive. It's calling receive right now, but receive does not return until something's actually there. Okay, and so we sent the first message. Now we've waited 5 seconds, sent the second message. Now we're waiting 5 seconds again. We're sending the third message, and it returns each time once we have something there for it. Okay. Now that's TCP. Let's continue with TCP for just a second. Now we're going to change something up. On the client side, we're going to send it in 3 consecutive calls. Okay, so we're going to call write, then we're going to call write again, then we're going to call write again. We're not going to sleep in between like we just did. Now instead, I'm going to come over here to the server side on TCP again. Okay, and instead of printing this stuff out, I'm going to comment this out. I am going to sleep for 5 seconds on this side before I call receive. Now think about what's going to happen here. What we're going to be doing is the server is going to be sleeping before it ever calls receive, and meanwhile the client is going to be sending the data over, so the data will already be there when it wakes up. The data from all 3 calls. So let's talk about what's going to happen here. If all the data is there and TCP, it's going to look at it and say, oh, well, this is just 3, there are 3 bytes there, we're going to grab all of them. Okay, so let's try it out and see what the difference is. So we're recompiling the server. We're going to start the server. We're going to recompile the client. We're going to run this. Okay, so we're sleeping for 5 seconds on this side, and then we get received 3 bytes from this. Okay, so again, TCP will grab whatever bytes are there, no matter what. Let's switch it now and do the same 2 experiments with UDP. So I think I got this one close. Okay, so in this case we're sleeping. I'm going to make it a little bit more like we did on the TCP case. So UDP client, we're sleeping now for 5 seconds before every single write that we make. Okay, and on the server side, right now we shouldn't be sleeping initially. Okay, so but we are going to put this printf in, just about to call receive from, and just returned from receive from. So what we should be seeing here is that we get a, what I'm trying to show you is that it's what we call blocking here, just like it did in the receive call from TCP. We're saying, okay, it's blocking here, waiting for some data to be there before it can return from this. All right. So let's see what happens here. GCC -o server x UDP server x udp.c. And now we're going to run the UDP server. Okay, so it's running. It says about to call receive from, and now it's calling receive from. It's just sitting there waiting for some data to come in. Well, it's going to wait for about 5 seconds because after we do this, because it's going to sleep. So UDP Okay, so what's going to happen? I'm going to hit this. It's going to wait for 5 seconds, then send the datagram with 1 in it. Then it's going to wait for 5 seconds, send the datagram with 2 in it. So we're counting down, 3, 2, 1, and there it goes. It returned 1 byte. Okay, not surprising. This is very similar to what we saw with TCP when we were waiting to send each one. So the server was anxiously getting whatever it had and returning it, spitting it out to the screen, whereas the client was sleeping and just putting one thing out at a time. Okay. Now let's do the reverse, just like we did with TCP. Now in this particular case, what we're going to do is we're going to remove the sleeps. We're going to send these all at once, and then on the server side, here's where we're going to modify things on the server side. So instead of these calls, these printf statements, we're going to right here call sleep 5. Okay, so before we even call receive from, we're going to call sleep 5. Now, if you remember in the TCP version, what happened was we slept while we were sleeping. It sounds like the name of a movie. The client sent all 3 of the bytes that it had to send. The 3 different messages all arrived. Okay, same thing's going to happen with the UDP client because we got rid of all the different sleeps that were down here. Okay, so client is just going to send away, whereas the server is going to sleep for 5 seconds before receiving. Now I want you to see the difference that happens this time. Okay, so we're going to run client xudp. We need to recompile up here. Okay, we're going to start up our UDP server, port 5599. Okay, so remember, server is going to sleep for 5 seconds. Client is going to send things without any sleep. It's going to send all 3 datagrams. Okay, so what are we seeing here? We're still seeing, even though the server had all of these, because it's sleeping each time, it's actually it's sleeping each time, and then it's grabbing what it can, and then sleeping again, and then grabbing what it can. What we're learning is with the UDP socket of type dgram, you can't grab all the bytes that are there because it's on a datagram boundary. Okay, you can only grab something from one datagram in UDP at a time. And that's one of the major differences between TCP and UDP. Now, let's go back and just take a look at what we've done here on the TCP side. Okay, so this this file descriptor right here, this is the socket that we've been using for our communications. This is the socket that was returned from the call to accept. Okay, so we've called listen on the socket that we created. We've called accept on that socket. Now we're looping on that client file descriptor that was returned from the call to accept to do this receive.